All right, so the last talk in this first session today is going to be from Yonny Cardenas from CC-IN2P3 in France. He was there 10 years ago. He's here today. No, he wasn't there 10 years ago. Wait a minute. Confused myself already. His talk is called iRODS Usage at CC-IN2P3/CNRS.
Thank you. Hi. I'm going to talk about we use iRODS at the CC-IN2P3. Sorry. Who we are? The CC-IN2P3 stands for Computer Center of the National Institute for Physics, Nuclears, and Particle Physics in France. We are located in Lyon. We don't make research. Only we provide the computer storage, the computer resources for different projects and for the laboratories of the institute. What the computer science provides storage and computer services for local users via local infrastructure and for grid and cloud services. It provides two database services and another kind of the services like hosting and emails. Currently, we have more than 2,000 active local users, more of them, some of them, for foreign users. We have 140 groups, active groups. Each groups correspond on a laboratory, on experiments or project. We have a computer cluster, actually more of the 40,000 core processors that is management with the batch scheduling system. For the data, currently we have 80 petabytes of the data storage in the different systems in disks and tapes. This is a description of the infrastructure, the storage infrastructure for disks. Concerning to the hardware, we have more of the 240 servers with direct attached storage servers that has a capacity around of 21 petabytes of the data, and another with the SAS servers around 3 petabytes. In the software side, we use parallel file system (GPFS), the IBM product that manage around the 3 petabytes of the data. But the most significant is the around 20 petabytes the data management with XRD and dcache. And for the disk part, and petabytes is management with mass storage systems, HPCs. We provide database infrastructure with different technologies, MySQL, Postgres, Oracle, MongoDB. And so this is around the 57 terabytes. In the side of the tapes storage infrastructure, we have 4 Oracle libraries with a capacity for 40,000 slots. This is a capacity for 320 petabytes, the maximum capacity. In the for the software for management the tape libraries, we have HPCC that actually management 16 petabytes of the data. A little story, because before the iRODS, there are another light too. We started in 2002 with SRB, that is for installation of SRB, and 2006 we installed iRODS, and 10 years ago we start with the iRODS in production, and this is continually in growth for usage. That's present the schema of the architecture for the iRODS in the server side. Essentially, we have two e-catalogs. This is the same two machines. That is addressed with the DNS alias. This configuration with two servers is for have the redundancy capacity. We have, for example, we have a problem with a server, another take the work. In backend, we use the Oracle database cluster. That is especially for scalability for the systems. For the DIGs, we have 17 data servers, around 1.7 petabytes of the capacity. The iRODS is front system for the mass storage system, for the tapes storage system. But we use iRODS to migrate the data from the DIGs to storage. In the client side, we have the clients, local clients in the cluster of the computer science, but many experienced use the computer centers in other countries, for example, in Italy or in Germany. Another features in the server sides of the iRODS installation, essentially, the services is interfaced with the HPC is for access to tape storage systems. We use the universal storage resource for make that. We use rules to management the disk cache in iRODS. That is essential for further data migrations into disks and the tape systems. The iRODS is used to make automatic replications to tape systems with another sites. For some kinds of the projects, we make automatic metadata extraction for make the ingestion of the data in iRODS. That is the case with the biomedical project for extraction of the DICOM metadata. Rules are used for customize access control list to data. This is the description of the user's profiles, the iRODS and the computer center. Research use the system from different disciplines, mainly for data sharing, management, and distribution. But in the same time, the data is used for processing, only storage, but two processings. The system is used too for archival, but not archival in the sense of the long-term preservation, is only with the massive storage. The communities that use the service is high energy physics, nuclear physics, astroparticle and astrophysics are the communities that more use the system, actually. And in the next years is the community more active. Another domains is fluid mechanics, nanotechnology, but we have the groups in biology, genetics, phylogenetics, and ecology. Another groups, projects for biomedical, for example, neuroscience, medical imagery, and pharmacology. But always we provide services for arts and humanities, archaeology, digital documents, economic studies, and for computer science. This is a picture of the different projects that use iRODS in different countries. This is very diverse utilization of the service, but different scientific domains. For example, we have the astronomy for the project OGRE in Argentina. We start the data for the Babar experiment in a Slack. For Virgo, this is another astrophysics project in Italy. We retrieve the data that the projects related with the International Space Station, but this is the case of the IMS and Euclid, and so. A couple of numbers about the iRODS. Actually, we have 25 zones, 46 groups, more of the 500 user accounts. We observe maximum 900,000 connections by day for around maximum what is observed 7.3 millions of the connections per month. Currently, there are in the system 164 millions of the files, or globally 16 petabytes of the data. That corresponds essentially 14 petabytes the data in the tape system. In the utilization continues to grow, so it's around the 50 petabytes by day. On the client side, we provide the service in an open way because this is the mission of the computer center. We have the users that access to iRODS directly using different kinds of the clients. The most popular logical is the iCommand, but we have the users and experience that use the PHP web browser, sorry. Other kinds of the users use the Explorer clients, like Ajux, that was developed in the computer science. And WebDAV is more popular. That are another not typical access. For example, the applications that use directly APA in C++ or Java, some in Python. And that is possible, or that is used, sorry, by the jobs in massive way. This is an example of the project that use iRODS. This is in the biomedical domain. This is a project that worked in the thrombosis modelization. And they captured data that the provenance of the different sources, for example, clinical, the biology, the imaging is together in the system, and this is shared what the people that participate in the project using iRODS. And the data workflow of the experience is integrated with the system. This is another experience in neuroscience, is for epilepsy treatment. This is based in the scanner of the brain for the people with HAPS is in illness, and the treatment, the image is treated in the cluster system, but after the results is stored in the system, and the patients are operated with its imaging processing, with the results of the treatment on an image. Another example in high energy physics is BABAR. It's an historical project. We archive we have the archival of the BABAR. Today is around the 2 petabytes of the data. We continue to make automatic transfer, the tape-to-tape system in a Slack and a Lion. The iRODS is used to make an automatic recovery of the problems with the transfers. Another example is, in particular physics, is Comet. Comet is a project that studies the instability of the electron. It's a detector that is built in the G Park in Japan. In it, there are the participation of the 50 countries, and the main reference data of the project is in iRODS. This is a typical schema that uses Comet for make the tracking and simulation of the events of the project. But in this case, iRODS is used with the reference. The data are produced in simulation and storage in iRODS, and automatically is transferred to the tape systems. But that this kind of the research sometimes start 4,000 of the simultaneous tasks, jobs in the cluster to trade to make the simulation with the data. The set configurations use iRODS and X-ray to obtain this scalability. Some needs and wishes. In this case, the patterns of the utilization, we need connection control, because sometimes we have massive and simultaneous access to the systems. That is better with improvements can be with the queued system to avoid the rejecting the connection immediately. Another one needs is rule management. Is maybe introducing a notion of the scheduling priority. It's not really a complex scheduling process, but it's something that can stick a name to a role to make basic management, for example, for identify data migration, etc. And another item important is the rule information to be stored in the database, in the catalog. Another one is possibility to install the system from compilation. That is a feature for the early versions, but now is maybe it's interesting to recover this feature. And support for PHP APIs, because there are the experience that use PHP APIs. To finish, some prospects. iRODS is the key for the CC-IN2P3 data management. We plan to make massive migration on the next year for the version 4, because the current installation is mainly in 3.3. Maybe in the next years is with version 4.3. And we want to start 2 projects, important projects for us, is a medium-term archival service, but is in the consistent in long-term digital preservation, based following the OIS reference model. We are working with the integration with Archimatica software for make that. Yeah, another project is the implementation of the matching actionable DMP for the data for management, the information related with data management plan. We are working with the software RDMO, and we expect to advance in this topic. Final acknowledgement, mainly Yonny, that is the storage team leader and iRODS administrator. Thank you.
So Yonny talked about a couple things that no one else has really mentioned yet. Mike touched on the data management plans and the preservation stuff. Is there anything else that anyone would like to ask questions about that has now been on the screen for the first time in the last couple days? They've been doing this for a long time, so they have lots of expertise. So he's asking how many people manage the system. Is it the ones on the screen?
In reality, is the half time of the Yonny is the only administrator of the system. The other people is essentially the support team to help him to support to users and the incidents. But in reality, is less of the half time of the Yonny.
So 25 zones. I mean, Yonny is special, but
that's good.
One. You just need one Yonny. Anyone else? So do you read and write to tape? Or only write to tape?
Mainly to write is generally there are a process that write in the tape. That's the point of the kind of the utilization, but because with that the massive production this is the like a Comet. We are using another system for spawn thousands of the jobs, but it's possible to read and write directly with the iRODS. That depends of the patterns of the access to the data.
So an observation on the connection client things. We have exactly the same problem for exactly the same problem. People can spin up 1,000 compute jobs and all of a sudden they're saturating our iRODS ingest. So something that we're looking at doing now that we've got the high availability IES with HA proxy in front of it, then you can use HA proxy to rate limit connections in such a way as it just feeds back very small amounts of TCP connections to keep the connection alive. So as for the connecting client, it looks like the connection is okay, just very, very slow. But what actually happens behind the scenes is it only lets through X number of connections at a time. That's the theory. I haven't got it working yet, but that's how we're looking to approach it at the moment. But I agree, like you, I'd like a way to kind of rate limit things, but it's very hard with any data thing to rate limit on ingest. You know, you can't control what's coming at you, basically.
So, sorry, can you repeat the question, please?
So it was more an observation on the fact that we're using HA proxy to try and rate limit clients coming in, rather than a question about how you're doing that.
So it's not a question. He's just he's explaining what he's done for the rate limiting at Sanger. Yeah.
Okay.
So yeah, we've talked about that for a while. We haven't come up with a good approach. Obviously, more people in the room who know stuff would be great. I mean, y'all are great. That's not what I meant. All right. Yeah, one more. Oh, suggestion from Raja, who will not be running the working group, that maybe Terrell should run a working group on connection control. Thank you, noted. Any other questions? Oh, we got a comment. Here's my.
No, you said one of the concern is about the client requesting a write in a queue manner, right? My suggestion is we are working with them also to make it this Python ingest framework to behave differently, not like on the back end running in asynchronous way. So one option maybe is, for you, is client will invoke the Python ingest, which will take a input the file, and that will asynchronously give a response back, put into the Redis queue, and then it can write back afterwards into the iRODS. That's an option. It's worth to try it out.
Yeah, the tricky part, I think, for CC-IN2P3 is they have so many different people with so many different clients already. There's no way to herd all the cats to use a new thing, right? But yes, that's definitely an approach too. We've started talking about putting that into the Python client. We could put it in any client, right? But that's the one where we've got the most uptake right now. Good? All right. Thank you so much.
Thank you.